Welcome to this masterclass on reporting results, how to write about uncertainty in your thesis. In the world of academic research, many students fear the word uncertainty, viewing it as a sign of weakness or error. However, in rigorous science, acknowledging what we don't know is actually a sign of strength and precision. Today, we will learn how to transform raw data into a narrative of scientific honesty. Section 1. The nature of uncertainty. Scientific measurements are never absolute truths. They are estimates. Whether you are measuring the growth of a plant or the impact of a social policy, your data contains noise. We quantify this noise using concepts like the standard error and variance. Think of it like a GPS. It doesn't say you are exactly at a point, but within a small blue circle of probability. Section 2. Confidence intervals, CIs. This is one of the most powerful tools in your arsenal. Instead of saying the average score was 75, a sophisticated researcher says the mean was 75 with a 95% confidence interval of 70 to 80. This tells the reader that if we repeated the experiment 100 times, 95 of those times the true mean would fall within this range. It provides a plausible range for the effect you are studying. Section 3. The p-value trap. Since the late 20th century, many have relied solely on the p less than 0.05 threshold. However, the American Statistical Association warns that a p-value doesn't measure the size of an effect or the importance of a result. Reporting a p-value without context is like saying a movie is long without saying if it's good. You must report the exact p-value, e.g., p equals 0.042, and never treat it as a binary true or false switch. Section 4. Effect size and practical significance. Imagine a new drug that lowers blood pressure by only 0.1 millimeters mercury. With a large enough sample, this might be statistically significant, but is it clinically useful? Probably not. This is why you must report effect sizes, like Cohen's d or r squared. These metrics tell your reader the magnitude of your finding, bridging the gap between math and real-world application. Section 5. Visualizing uncertainty. Your graphs should speak for themselves. Avoid simple bar charts that hide the distribution of data. Instead, use error bars, shaded confidence bands in regression plots, or Raincloud plots that show the raw data, the box plot, and the density all at once. Visualizing uncertainty makes your thesis transparent and much harder to criticize during your viva or defense. In conclusion, writing about uncertainty isn't about being unsure. It's about being precise. By using confidence intervals, reporting exact p-values, and emphasizing effect sizes, you demonstrate a high level of statistical literacy. Remember, a thesis that maps the boundaries of its own knowledge is far more valuable than one that claims to know everything. Good luck with your writing.